I have been writing a script for the next installment of my 3D printed knitting machine series for what basically feels like an eternity now. It's all about the design process. It really covers all the little problem-solving steps that I went through to get from the idea to a sort of finished product. And I'm super excited about it. But, it's just a lot. It's a lot to cover. I'm up to about 6,000 words, and that works out to roughly 30 minutes of pretty brisk talking, and I'm not even really close to done. So I can already tell that this is going to be just too much for my little goldfish brain to remember on camera without some kind of assistive technology. I also just feel like hot garbage today, and I've got hella writer's block, and my brain is just begging me to do anything else aside from think about knitting machines. And unfortunately, I'm not currently on speaking terms with my current sewing work in progress, so I've got to come up with some other way to procrastinate. So I'm going to do what any rational person would do and make a teleprompter.
So I do actually already have the physical side of this handy. I threw it together for a previous video. It's literally just an angled pane of picture frame glass and some foam core board duct taped together and then hot glued to a squeegee pole. I slide my iPad mini under the glass and position my camera behind it, and then the angle of the glass allows me to see the reflection of the iPad screen when I'm looking straight at the camera, but that light is deflected away from the lens, so it doesn't mess with the image being recorded. Simple, but clever. There's plenty of good tutorials out there, all with sort of slightly different methods, and I'll link the one I loosely followed in the description. I'll probably eventually get around to sprucing up the physical build as well, but the thing I really want to focus on today is actually the software side. The hack I used for that first video shoot was to create a slideshow presentation with Keynote, which allowed me to display the text on the iPad while controlling the presentation remotely from my phone. This actually worked surprisingly well during the shoot. It wasn't always perfectly synced to my speaking pace, but I got it close enough to be useful, and it was fairly straightforward to control from my phone. The big downside was that it took a really long time to create all of the slides manually, and it was a huge pain in the ass to change anything if I had to edit the script at the last minute.
I think we can do better. I think we're gonna write some code.
Step 0, forming a plan. So there's lots of ways that I could approach this, but I decided to brush off my old buddy P5js. P5 is the web-friendly JavaScript-based version of the processing programming language. And I've already done quite a few projects with processing and a few with P5 in the past, including one that I might use as a little bit of inspiration later on. I'm also going to build this project on a fun little coding platform called Glitch, which means I won't have to worry about any of the deployment details, and I'll be able to see everything live on the web as I go. So here I'm going to remix the blank starter template for a basic website on Glitch and give it a bit of a more descriptive name. Then I'll delete the HTML code I don't need and grab a link to the P5 library so my site knows where to find it. I'm also going to change the name of this JavaScript file to sketch.js. This is not only more conventional for P5 projects for the main file to be called sketch, it's also going to make things just a lot less confusing when I'm trying to distinguish between the video script and script as in JavaScript. So from now on, my JavaScript is going to be known as the sketch. Step 1, get some text on screen. So in my sketch.js file, I can delete the code that was in the Glitch starter project and start replacing it with some P5js. Most P5 projects need to include both a setup function and a draw function. Setup contains code that runs once at the beginning of the sketch, so it's usually where you tell it how to do important one-time foundational things like, hey, make a canvas for me to draw on. And draw is a loop that runs over and over and over again until you either tell it to stop or you close the sketch. This means that the draw loop is usually what controls any animation or anything else that might change over time. If I don't put any instructions in draw, then whatever gets put on screen during setup will stay there. I can draw some text on screen now by calling text hello world 0, 0. The first argument inside the brackets tells it what string of text I want it to write, and you have to make sure if it is something literal that you want it to write on screen that it's inside those quotation marks. The second argument is the x-coordinate on the canvas, and the third is the y-coordinate. The x-coordinates run horizontally from left to right, just like you might remember from math class, but the y-coordinates run from top to bottom, at least for now. The origin point, or 0, 0, of my canvas, by default, is the top left corner. But the default text alignment is actually from the bottom left side of the text. So we can't really see much right now until I change something. Let's set text align to left and top and move our message position to give it a 15 pixel margin. The starter code I'm using here sets the background to this light gray color, but for my teleprompter, I think I probably want a dark background. I can specify this by changing the number inside these brackets. If I give background just one argument, it will interpret that as a grayscale value from 0 to 255, with 0 being the least bright, or black, and 255 being the brightest, or white. If I were to give it 3 arguments instead, I could set the red, green, and blue values of the light from 0 to 255 independently and start mixing colors. Of course, now that my background is black, I can't see my message anymore because the text was also black. To change this, I have to set a fill value before I draw the text, and that is going to say what color anything other than the background should be filled with. Something with a high contrast will show up best on my teleprompter, and of course, white would be very high contrast with black. But personally, I have found that the text is a little bit easier to read if it's in more of like a pale yellow. I probably also want to make it a little bit bigger than the default, so I'll set text size to 18 for now, but I probably want to come back and fiddle with that later. Finally, I want my canvas to fill the whole window, so I'll change the canvas size to window width and window height. These are built-in values that P5 supplies. And by the way, if you notice that your canvas looks like it's the right size, but it's a little bit offset from the top left corner, there might be some styling on your web page that's not actually controlled by P5, like in this CSS file. I fixed this by setting the body margins to 0. Step 2, load the script from another file. So now we can get some text on screen, but the spot where I'm telling it what I want it to write is right in the middle of all this other code. And that's fine when it's just a word or two like I have here, but obviously the whole point of this is that my script is going to get really long, and if I try to copy paste that whole document here, it's going to get really messy. So instead, I'm going to put my text in its own file, and I'll call that myscript.txt. Then I have to tell the sketch where to find that file and what to do with it, with load strings. First, I should declare a variable here so that I have a way to refer to said strings once they are loaded. Second, I'm going to add in this preload function that P5 provides, which acts as a sort of pre-setup area. So anytime you have to load external data or fonts or images that your sketch relies on, it's a really good idea to make sure that those are ready and available before you start trying to do anything with them. Otherwise, your sketch is probably going to crash or hang or do something unexpected. Now, if I declared my script inside of preload, it would have local scope, meaning it only exists inside that function, and none of the other functions would be able to use it. So I'm declaring the myscript variable outside of all of these functions because I want all of them to have access to it. It should have global scope, but I'm not going to assign anything to that variable until I've loaded the text file here in preload. So the first thing I notice is that the text isn't wrapping. It just keeps going and going on one line until it wanders off the edge of the canvas. I can fix that by adding another argument to my text function to set the width of its bounding box. So I'm going to use the full width of the canvas minus the left and right margins. And since I probably want all the margins to be the same for now, this is a good time to assign this value to a variable. Then if I want to change the size of the margin, I can update it all in one spot instead of having to remember to change hard-coded numbers in all of these different places. So in this case, my script actually has lots of paragraphs, and those are all separated by line breaks. But what load strings does is it actually treats each of those line breaks as a way to break down the file into individual strings of text. And it loads those strings into a data structure called an array. Each string occupies its own slot or element of the array, so that works out to one paragraph per element. If we just tell our text function to use that array as is, then behind the scenes P5 is going to automatically try to join all of those separate strings together using its default separator. It's not going to know that they were originally line breaks, it's just going to use a comma to separate them. So we get this big ugly wall of text with random double commas sprinkled throughout, which is not really what we want. What I can do is add a second argument to load strings where I give it a callback function that will run as soon as the strings have been loaded. And this is where I can go do any cleanup or formatting that they need. I'll call this handle strings, and I'll define what I want it to do down at the bottom of my code. The callback is going to automatically supply this data from the load strings array. So now I can say I want to join the data array with the line break separator and assign it to the myScript variable. Step 3, animate the text scroll. So far, we're getting lots of text on the screen, which is great, but it just sits there. If I want to make it scroll, I have to do some animation, and that means I finally get to use the draw loop. First, I'm going to move all of this stuff that I want to draw from the setup function down into draw. And even though it's drawing over and over again, it's not actually going to look any different than when I was just drawing it once because I'm not actually changing any values in the draw loop yet. So if I want to do that, I'm going to set up a couple more variables that I can use to keep track of the things that I do want to change. I'll keep my margin for the left and right sides, but I'm going to add a top Y value to position the top of the text. This is the value that I'm going to be changing each time the draw loop runs to make it scroll, but I'll have it start at the same value as our margin just so that our original text isn't squished all the way at the top of the canvas when you load it. I also need a value to control the speed of the scroll, which I will creatively name scroll speed. I don't actually know exactly how fast this should be yet, but my frame rate is going to be about 30 frames per second. So if I set the increment to 0.5 pixels per frame, then things should move about 15 pixels per second. My text size right now is 18, so this should kind of get me in the neighborhood, but like maybe the suburbs of 1 line per second. That's probably too fast, but it seems like a reasonable enough place to start at least testing things out. So now in draw, I can change this Y parameter to take top Y instead of margin, and I'll add a line at the end of this loop to change top Y by the value of scroll speed. I want the text to scroll up, which means the new Y position is going to be less than it was before. So I want to take the previous value of top Y, subtract the scroll speed, and then reassign this to be our new top Y value for the next frame. Ta-da! Step 4, mirror the text. When I display this text on my device, I won't be looking at the screen directly. It's actually going to be reflected into that pane of glass on my teleprompter. So I need to mirror everything. I can do this with a scale transformation. So in my draw function, before I draw my text, I'm going to put scale 1, -1. What this says basically is multiply everything horizontal by 1, so they stay the same, but multiply all of my vertical or Y values by -1, so they're going to get flipped over to the other half of the coordinate system. Now, because our origin is still in the top left corner, the other vertical half of this coordinate system is going to be like way up here off the canvas where we can't see it. So what we can do is move our origin with a translation before we do that scale. And I'm pretty happy with all where my x-coordinate stuff is, so I'm going to leave that first value here at 0, and I'm going to translate vertically by half of the canvas height, so that axis of transformation is going to be right across the center of what I'm seeing. So I could have translated it by the full height of the canvas to get sort of an exact opposite of what I was seeing before. But I actually think having the text start in the center of the screen, now that I'm looking at it, is probably a little bit better for my eye line when I'm trying to read this down the center of the lens. Plus, it means if I want to turn the mirroring on and off, I can just change one line instead of two, and it makes it a little bit easier to flip back and forth between them. Step 5, improving readability. So things are looking pretty good in my preview pane here, but an important thing to keep in mind is that I'm going to be looking at this on screens with various sizes. If I open up the page in a new, bigger window, suddenly the canvas is a lot wider. The letters feel smaller relative to the whole window, and the text becomes just harder to scan because the lines are so long before they wrap back around to the other side. I could increase the font size, but then when I go back to the smaller window, suddenly things will be out of proportion again. So as a teleprompter, the whole point of this program is to make a script easily readable on camera so that it feels comfortable for me as a presenter and that it comes across as naturally as possible to an audience. A big component of readability is not just the absolute size of the font, but the number of characters in a line. So the ideal line length depends on the application and the individual person, but somewhere between 45 to 75 characters generally seems to be the sweet spot. So instead of picking a specific font size, I want to define the font size as a proportion of the canvas so that I'll get a nice line length regardless of my device. After a little bit of trial and error, I found that dividing the width of the text box by 30 got me roughly in that range, though your mileage may vary depending on the font that you choose. Speaking of fonts and choosing them, I'm going to replace the default font here in P5 with something that's a little bit nicer to read. I chose Roboto from Google Fonts, and I've got it here. I'm going to upload this to the Assets panel of my Glitch project, click it to copy a link, and then I can preload that into my sketch, assign it to a variable, and set the font down in Setup using text font. Step 6, add some controls. So now I want to add a couple of simple ways to control the playback. Normally, I would put some kind of explicit visible user interface on screen for this. So probably like a button with an associated keyboard shortcut. But given the application, I think I really want to prioritize not making the screen cluttered because I don't want to risk distracting from the reading experience, which is the whole point. I definitely want to have a way to pause and restart the text scroll. So let's start with that. First, I'll create a variable that will keep track of whether the text is currently scrolling or not. This will be a Boolean, meaning it's either true or false. Now I can toggle the value from true to false and back again in response to an event that comes from my mouse or touchscreen or keyboard. P5 has some really handy built-in event handling, and in the reference docs you'll find I have a bunch of different options. Play and pause seems like a really fundamental action to me that I want to be easy and quick to do without having to think too hard about it, so I'm going to make that just a single click or tap anywhere on the canvas. Inside this mouse clicked function, I'm just going to set the value of is scrolling to exclamation point is scrolling. The exclamation point means not. So this says take whatever the current value is, whether that's true or false, and make it not that. So if it started as true, it's going to be false. And of course, just toggling the value of the Boolean isn't enough. We actually need to tell the draw loop how to use it. Here, I'm moving my scroll calculations inside a conditional block. This says only run the code inside the curly brackets if the condition inside the round brackets is met. In other words, if is scrolling is true. So my original narration here was a whole bit about how nice it is that P5 automatically translates mouse events to touch events, but it turns out that this wasn't actually working for me, and I did have to add separate touch control later. Whoops. However, if I want to be able to use the keyboard to control these actions, I do have to add that separately. And even though it might seem a little bit weird and redundant to be thinking about adding a whole separate key pressed function that will duplicate stuff I can already do with pointer devices like a mouse or a touch screen, I can't guarantee that I or other users will always be able to use those devices. Sometimes a keyboard or something that acts like one might be my best or even my only option to access this sketch. So I think it's a really good habit to get into, just thinking about making sure that pointer events always have keyed counterparts and vice versa. Step 7, remote controls. I now have a cool little web app that can put my script down, flip it, and reverse it, and look different on different size screens. Even have some handy playback controls. But what I can't really do yet is use those controls from across the room. I have two kind of wildly divergent ideas about remote controls for this sketch. One of them involves an actual physical hardware device that will act like a little wireless Bluetooth keyboard and connect directly to my iPad. So if you thought that last section sounded like foreshadowing, you're not wrong. But I do also really like to remind people about accessibility whenever I get the chance. But, if you've been following along and you already have an actual Bluetooth keyboard that will connect to your iPad or whatever device you're planning to use in the teleprompter, then congratulations, you're done. You can go home now. The other approach involves networking. Yeah, like servers and clients and something called WebSockets. Both of these are pretty much projects in their own right that probably deserve their own videos. So I'm going to call it a day here, but future Sparks will be back to share the good word about Arduino and Node.js soon. Until then, stay curious.